Okay, so as a record, all of the students was attend today. All of them are here. And we continue with our question. So if you look at tutorial question 16, so the statement given, right? Water flowing from an oscillating slit as this diagram. So there's a diagram in your tutorial sheet there. So produce a velocity field. So again, velocity field, you have 3-dimensional, 2-dimensional, and 1-dimensional. So by looking at the equation here, you see I and J, you do not have K component, so you only have a 2-dimensional question. So where U0, V0, and W are constant, so it means that you can factor out all these terms later on. And y component of the velocity remain constant. So it give you the y component value with its v equal to v0, and the x component velocity at y0, it collides with the velocity oscillating sprinkle head, giving you a equation here. So means at y0, your velocity at x direction, this is a small u, means it's in the x direction. You have a one equation here. So you have 3 instruction to determine straight lines, and then you're giving the time condition. Now again, for fluid mechanics, we always look at coordinate x, y, and z, and then plus location. Location was given by the time. Okay. Now you need to determine t is equal to 0 and also another time t equal to pi divided by 2w, and so on. So let's look at the first one. How we're going to solve. So we're going to look at the first one. Determine the streamline pass through the origin at t1 here and t2 here. You have 2 scenario condition. So if you look at the diagram here, you was given the reference axis. You have x and y, and then your q is from bottom. So again, you look at the velocity field. You write the velocity field equation, v equal to as given. U not sine something, I hat means this component is x direction, and then this is y direction. You see j hat there. Okay, right. Now we know that we can break our component, our velocity field, into 2 components by looking at their vector sign. So all the direction in x-axis we denote as small u, and then you copy the first term as your magnitude of your u component, small u in the x direction. Then you copy the y direction, which is given by the small v equal to the value that you see in the equation. So this is the standard procedure, right? Standard procedure that you should always follow when it comes to your exam or your test. So you look for the velocity field, one equation, then pull out the u and y or even z direction. If you see a plus something k hat, means you have a z direction, meaning here you need to add w, small w for z direction, equal to whatever is given. In this case, you only have a 2-dimensional question. So you always get, for streamline, SOP, standard operating procedure, you always write this equation, dy over dx equal to v, means velocity in y direction, divided by x direction. dy dx equal to v divided by u. And this one was covered in the previous lecture slide. All right, if you don't understand, go and refer it later on. All right. Now, do stop me if you have any question. You don't understand any equation on the screen. Just stop me before I move on. So after you get a differentiation equation, this is a standard equation to get streamline. After you get this one, then you integrate this equation, meaning you pull dy one side and then dx one side, and then you integrate. Okay, so you put in the u you substitute whatever you see in the equation just now. So V is V naught. U is the equation given here. It's a quite big, lengthy equation, but don't worry, just follow the principle, because in the exam, all this will change. You just need to remember the general steps, right? So once you get this one, you move X and Y to one side. So you pull all the term Y to the left and the X to the right. So you have this one, and then you put the integration sign in both sides. Then you get this one, okay? So this is the standard step to get Streamline. So in exam, what is the marks will be given? So I will give you some idea how I marks. So for example, in final exam, what are the marks will be given? So the first one, you write the equation here, you write out this one, velocity field, meaning that you understand what is velocity field. And then you write these two. You write these two, all right? So this one will give you 1 mark, this one will give you 1 mark. If you have a Z component, W equals something, if your equation here got Z direction, then you get, you write the Z component, you get another marks. So 2 marks for this question now. And then you write, to get a streamline, you write this equation, you get 1 mark. Then you rearrange from here to here, you get another marks. Okay, you write this one, and then you chain this one, you rearrange to get the integration equation like this one, you will get 1 mark. So by starting point from here up to this line, you get 1, 2, 3, 4 marks for here already. So it's very easy to score as long as you follow the procedure. In exam, this one will change. So don't be scared by the very complex equation. You will see I, J, and K. That is the main things. And then whatever in front, the I hat, J hat, or K hat, that one will become their constant. You just pull it into the equation. All right. Now, then you continue with the integration. So integration, I will not, how you do integration, I will not cover in this module. If you forget already, go and dig out all the calculus textbook and go and see, or you can go on YouTube and watch how to integrate something. All right, so you integrate sine, you get cos. Yeah, then you integrate something without x, you add a x behind the term there. This is constant value. You integrate something with x, there's no x there, you just add an x. Then plus a constant value. Because why we have a constant value? Because in the integration process, if you don't have the boundary condition, you don't have a boundary condition at the symbol here, you will get a constant value here. Okay, now we need to solve what is the value of a constant value. So we just call out the coordinate that you know. For example, what coordinate you only have 2, x coordinate and y coordinate. So in the question you have given the coordinate already. All right, so when x equal to 0, your y equal to 0. And then for the streamline at t equal to 0. So we have one set condition here. So at origin, at here, if you look at the diagram, this is the origin. So at this point here, your x and y coordinate is x equal to 0, y equal to 0. And then the time that you need to solve for section A here is t equal to 0. Later, you need to consider the second one. We look at the first condition, which is t equal to 0. Then you substitute all this value inside here. So x0, so this is 0. I don't need to do, so this one 0. Y0 here, so this one 0. T0, this is 0. So this component is 0. Cos 0 equal to, let me call out name. Brian, what is cos 0 equal to?
Cos 0?
Yeah, cos 0 equal to?
Is it
Equal
like
to what?
90?
Cos 0 equal to 90? No, it's a constant value. Cos 0 equal to what? Is it 0 or 1?
Oh, 1.
1, cos 0 equal to 1. Okay, so this one you need to remember, because in this module you will deal with sine value or cos value. So remember on that. Or that one you can find with your calculator if you forget. Okay, now if everything boundary condition you apply to this equation, you will get your constant value C equal to this term, U0 V0 divided by W. So this is a constant value. All these are constant value, and it was mentioned in the question statement. You just put as what they are. Then after that, you pull this term inside the equation. You pull inside that the equation, then y in one side, x in one side, because this one gives you the streamline pattern. In question 7, I did show you how to do it already. So this one we also will use the same method. So we have this equation already. So you see, from just now, what we do is that we form a general equation. We pull out the x component, the velocity in x component, velocity in y component, and then we call out the general equation, dy over dx equal to v divided by u. Then after that, we substitute the x and y component equation inside here. Then we change the differentiation into integration relationship. Then after you complete the integration, we have one constant value here. So constant value here, we need to find. How we find is that we apply the boundary condition. So this is the boundary condition where you've in the coordinate here. So x equal to 0, y equal to 0, and then at the time equal to 0. So you apply this boundary condition inside this equation, then you find the c, the constant value. So after the constant value, you sub inside there, and then move everything one side, means y in one side, x into one side. Okay, this is how we solve for streamline instruction. Okay, equation for the streamline, we rewrite the whole thing. Will be like this. So you can see the same term here. You can factor out u0 divided by w. You factor out, then you make the rest inside the column. Now, how do I mark usually in the exam? So let you know. So calculation part, where's my mouse? Okay, here to here, I'll give you 1 to 2 marks in exam. Here to here, you'll get another marks. Then after you rearrange, this one will get another 1 mark. You rearrange, sometimes this one will have marks, sometimes we don't have marks. All right, so normally I will be generous, so I'll give you 1 mark. So after you rearrange in the presentable form or simplified form. Okay, yeah. So any questions so far? Any question? Stop me if you're not able to understand. You can ask, hey, Dr. Ang, how come this equation come from? Any term that you don't understand. Okay, clear all your question before we move on. And then just a reminder, for this module, it will be an open book. It will be an online test, meaning you'll be given the opportunity to open up the textbook. So the question will be very challenging. So we were testing your intelligence in understanding the basic, the fundamental, meaning it won't be one-to-one question, meaning it won't be the same as in tutorial, but it will be your understanding in the principle will be tested. Right, for example, this question tests you how to build the streamline. So you have to understand what is the procedure. Okay. All right, we move on. So we have already cleared the first scenario at time equal to 0. Here, we already clear this one. Now we're going to look at t equal to pi divided by 2w. So how we going to solve it? Same thing. You call out the equation because once you change the time, your constant value will change. So again, we find what is the value of this constant value. Apply the boundary condition again. This time your t change, no longer 0. Now it's t equal to pi divided by 2w. You substitute everything inside this equation, you get your c. So again, if you substitute this one in there, you will see cos pi. Cos pi is 180. 180. So your c equal to 0. Okay. Then you know that this one is 0 already. Again, is at a t equal to pi divided by 2w. So your equation equal to this one. Okay. Again, once you rearrange, you take out your v already. Not v already here. Take out already. This one don't have, this one don't have because you cancel both sides. So that's why at the end, this equation will become this one. So far, we're just canceling things and also applying the boundary condition. Then we get one equation for this one. So we have two equations for instruction A. Meaning question 16, instruction A, you have two answers. One is this equation. This one. And another one, this one. Okay. Yeah. All right. So you do the same also. So you have this one will have 1 marks. So here to here, you have 1 mark. And then this one will have 1 mark. Okay. So this is how, by seeing the question and then you see the marks at the behind the question, then you will guess. You can estimate what are the steps, how many steps that involve. Okay, this is how normally it will go lah. Okay, all right. So again, this one, the equation just now. All right, equation just now. Because here after you rearrange, you can cancel your w here again. So you can, so this equation become this one. So this is just you change this equation in the more needy terms, because you know that cos pi divided by 2 minus something, you can write in this term. From cos into sine. So this one, the relationship from the left equation to the right equation, this one you need to check the trigonometry chapter. This one in the advanced mathematics. All right. You change cos pi divided by 2 minus something, you can convert this term into sine of this term. This one covered in trigonometry. Okay, good. Now, okay, I forget to hide this photo. So at t equal to 0, you get this equation. At t equal to pi over 2w, you have this equation. So you will have this diagram. So now I want you to scratch, copy this shape of a graph on the screen, what you see here. Copy this diagram on your notes, or on your tutorial question. So your y-axis is y-axis, your x-axis is the time, and the value is given here. One is negative, one is positive. Okay, just copy this shape. So one is solid line, one is the dashed line. So the solid line is t equal to 0, right? So on the last Tuesday, I did show you the online graph plotter online. You just key in the equation, x equal to, this one is the constant value, right? You just key in some constant value there, maybe 1 or 2, right? Usually if it's a constant value, I will put 1. So 1 cos w y divided by v0. This one also you put a value there. Or theta, you put it theta minus 1. Then you'll get this kind of graph. Okay. Same with the t equal to pi divided by 2w equal to this one. Okay. So this is for section A. Section A. So Praka, you are new. So in this module, you can use online platform, means you can use website to plot graph, and then you copy the shape from the graph, and then you put into your answer. Right? Because in this section, in this module, I do not test your skill in plotting graph. I just want to test your whether you understand how to get the answer. Okay, we look at another one. We look at number 2, path line. Path line. Okay, path line. Definition, path line in a previous slide. We can obtain from the velocity field and definition of velocity. So again, you call back the velocity field from the question. And then what is the definition of velocity? Means the change, the distance change in the x direction, and also the distance change in the y direction. So if it's linked with the x direction, then you use a small u. U equal to dx dt means u is the change of distance in x direction with its velocity or speed. Be careful on the word speed and velocity here. Speed is only a magnitude. However, velocity is a vector. Velocity is a vector. So vector have direction and also magnitude. Be careful on that. And then v also same. V is a y direction component, dy over dt. So what you do is that your u is the first component here. This is your u, small u. And then this one is your v. Just copy. So dy dt equal to the what is in front of the I hat. This is your u component. And then dy dt or your v component equal to what is in front of the j hat. Again, in final exam, maybe it will become a 3-dimensional question, which is you will have something k hat. So you will have w equal to dz over dt. So just take note. So if you have a w, then you have dz, because in the z direction, dt. So if you have something here in final exam, you will see something k hat here. However, this is a 2-dimensional. So just make some notes on your tutorial question. Maybe it come out in the test. So just take note now. So and also if in exam, if it's a 3D question, this one, if you do not write dz, you write dx, I will give you wrong. I will give you wrong, and I will give you wrong for the x, because it contradicts to what you said in the question, in your answer. Okay, so this is what you're going to do.
So what if we call it p?
Sorry, again?
What if you do decay instead of dz?
Okay, so what you do is that you just because it's in the z direction. So if you have a w here, so you write w equal to dz. You just write dz. Because some student they forget how to write this one. They will straight away they will just give me the x over the t equal to w. Then I will see the repeat of your u and w, meaning you don't understand what you're writing. Do I clear the question just now?
Yeah.
Yeah, okay. So this one we don't have w lah, so I just erase. Okay. Now the next one is we integrate to get the y component. So you integrate your y, this one. You integrate your y, so you just integrate y. dt you pull to this side. Integrate dy, integrate dt, you get this equation. Okay, maybe I'll write it for you here so that you can see how you get this one to here. You just add in the integrate on both sides. This one you have dy. This one you have v0 and then dt. So you integrate y, dy, you get y. Integrate this one. This is the constant value. You have nothing. However, you integrate with dt, you get t. And then one constant value there. Okay, I'll erase. Then for dx, you do the same. You do the integration also. Mean you pull the t to the one side, and then you add in the integration sign. So integrate sign something, you need to refer to your notes lah. Okay, so you get this one. You refer to your mathematics notes how you integrate sign something. Okay, this one here to here, you refer to your mathematics notes. Okay. So you get negative u0 sine something. How it come from here to here is a mathematic procedure. You go and read your calculus or advanced mathematics procedure. Okay. Then you integrate. So integrate, you get this one. X equal to minus u0 sine, this one, and then constant value. So one is for y, one is for x. So you have two constant values, C1 and C2. Okay. Now we have from the velocity field, we use some procedure. We get our y equation, we get our x equation. So again, this equation, we have two unknown here, two constant value. So we need to find out what is all this constant value. Same procedure, we call out the boundary condition. So boundary condition, x equal to 0. We always find what is happened to the origin within here. Here, this is the origin of the axis, x equal to 0, y equal to 0. At time equal to 0, because in section B, it gives you two location. One is e equal to 0, t equal to pi divided by 2. We look at the first coordinate first, which is t equal to 0. You substitute all this inside this equation. You're able to find. You're able to find for both C1 equal to C2 or equal to 0. Because t equal to 0, 0, y 0, so your C1 equal to 0. And then for the second equation, this one, your C1 is 0. So this one 0, t 0. So this whole thing 0, x 0, so C2 equal to 0. Then you rearrange again these two equations with the coefficient value. In this case, coefficient value equal to 0. You just rewrite to this one. So How we know that x equal to 0? Because this whole thing equal to 0. Sine 0 equal to 0. Huh? Sine 0 equal to 0. Cos 0 equal to 1. Okay. Now then this one, y equal to y 0t. All right. Any questions so far? This one is for path line. Path line is linked up with the velocity. So we just clear two concepts here. So path line is linked up with the velocity, which is dx dt and dy dt, and one more is you have a three-dimensional, it will be dz dt. This is linked up with the path line. And then the streamline is always linked with the definition of streamline, dy dx equal to v divided by u. This is in the plane, 2D plane condition. This one is in the xy plane, xy plane. Okay, we have clear streamline, how we do it, path line, how we do it already. Okay, we do for the path line, t equal to 0. We need to clear one more. T equal to pi divided by 2 for section B. Do the same procedure, only change the boundary condition. So now you change the boundary condition, t equal to pi divided by 2. Substitute inside there. You'll get C1 equal to negative this term. C2 equal to pi u0 divided by 2w.
W.
Yeah, w. It's a rotational, w is a radian per second, the unit. This is a circular speed, circular rotation. W. So again, understand the procedure rather than memorizing what is all these complicated equation. Memorizing the steps for what we are trying to do here. Okay, once you get the constant value C1 and C2, substitute back, then you get the equation already. Substitute back. Okay. Then you get the equation. So path line for second condition, x equal to u0 times something, y equal to v0 times something. So this is how we get the path line. This is section 2. Any question on the procedure? Any question? Maybe some of you is still copying the answer. It's fine. I give you some time to copy. If any question, ask me now about path line.
Sir, can look back at the streamline part.
Streamline, which part you don't understand?
I just want to see the.
You mean section A?
Yeah.
You want to see which one? The procedure. The procedure, is it? This one? Oh, this one. Or previous slide, this one. Or this one.
Wait, sir.
This one. This one, is it? This one, right?
Yes.
So yeah, for streamline, we always start with the dy dx equal to v divided by u.
So what if this has the z direction?
You mean the direction or what?
I mean, what if there's a k behind the v velocity?
Again, I don't understand your question.
Velocity given by V equal to U sine whatever things, right?
Oh, you
There's
mean this equation, is it? This equation.
there's only I and J, right? What if there's another K? Then what to do with the dividend?
Okay. Now, if there's a three-dimensional, I will mention in the question. Treat the question as a two-dimensional question. Focus only on the I and J component only. So for example, Brian, can you mute your mic? And Chia, can you mute your mic? Okay, so I'll use your mic. Okay, now just now there's a questions. Let's say we have V1 K here. So this is a three-dimensional. How we link with this one? So normally, if you have a 3D, the question will say something. Okay, the question, I will just type it out so you can see. The question will mention. Oh, so you have a. Let's say you have a. Let's say you have a third component. And then K. Oh, not this one. Let's say you have this one. Now the question will very specific mention. The question will guide you through. So at the end, you still use the dy over dx minus VW. So focus, not focus. Professional ways, it will ask you consider only y plane you'll see this one in the question. If you're given a very lengthy 3D film like this, then you solve using this one. The rest is still the same.
Okay, sir.
So if the question again want to add more challenging, you will see there's another line come out. You will see consider y z plane. So yz plane, when it comes to yz, means you will have z divided by y, something like that. But again, just for the tips, I won't ask you these complex things. Okay, we looked at the path line just now. So we have two equations just now. Two equations. So the path line can be drawn like this. So the path line you plot on the locus value of t more than 0, meaning your time equal more than a positive value for your t. Because you're seeing these two things, these two terms is almost the same. All right, then you can write this one together. Path line in x direction, path line in y direction. Then you know that you're seeing that you write the same, meaning okay, you're seeing this one is the same, right? This is the same term here. So you write this one. So you move this one, x t equal, sorry for my writing using my mouth, t minus pi divided by 2w equal, you rewrite this equation equal to x divided by u naught, u0. Here on the y component also same, t minus pi divided by 2w equal to y divided by v0. So these two is the same thing because they are equal, both equal to t equal to pi divided by 2w. You rearrange these two together, you get this one. This one you rearrange, you get this one. Meaning x divided by u0 equal y v0. You rearrange y in one side because you want to get in equation y equal to, again, you know that in mathematics we always will put in the either linear, this is a linear lah, y equal to mx plus c, or if you see the x square one is y equal to the general term ax square plus bx plus c. Okay, the most for this module will be power 2 lah. Power 3 will be a bit complex already. So in this case, we can see that this one is the linear equation, y equal to mx plus c form where our c equal to 0. And then this one, m is the gradient, so this is the gradient. This is your gradient. When you plot this one, then we'll get this. So copy this graph for answer section B. So when t equal to 0, your x equal to 0. When t equal to pi divided by 2, then you get an equation. This is y equal to mx plus c. This is a gradient. So we know that this is positive. There's no negative sign here. So every time you have a positive gradient, you will be in this way. Your graph will be going up like that. This is a y, this is your x. So y equal to mx plus c with your m more than 0, means positive. Okay, again, this one are all covered in your advanced mathematics already. Right, so this is the answer for B. Answer for B. Let's look at C. C is about straight line or stick line, pass to origin. So at origin t equal to 0, the locus of the particle at t equal to 0 will be like this. So this one will be a bit complex. You copy down. You copy this diagram. Just draw out the shape. You start with the axis, x and y axis, and then you draw the path line. Just now path line, we only look at one of the time. This is t equal to t1. Let's say this one is our question, t equal to 0. This line equal to t equal to t2 equal to something else, equal to one of the constant value. And this line will equal to t3. We have a value there. So you get the graph, straight line like this. This is a path line. Okay, and then you see what is the definition of the stick line? It's just a repeat of the previous particles. right? It flow through the origin. So for example, if in this case, we have a path line within, let's say we have this line and this line. So let's say we have a two t lah, right? T equal to 0 and t equal to some value. Okay, for example, this one t equal to 100 lah. So at the time after 100 seconds, then the stick line, the path line will move from the right to left. Then your particle will always your stick lines, your particle will always move in the sine wave like that. You always hit on the stick path line. Okay, this is the straight line, stick line. Okay, copy the graph. Okay. So we solved for question 16 already. This one you can read later on for my slide. I'll upload in the Moodle later. Okay, all this you can read later. Okay, you copy down the shape of the answer for section C. Okay, with this we clear chapter 1. Let me end the recording for our first session.